This is Physical Science 2, Chapter 20, Part 2 on Earth Materials. In this portion of the video lecture, we will be discussing igneous rocks. Now that we've learned about the materials that the Earth is made out of, with minerals, we can take a look at rocks as well. So what is a rock? Well, because minerals have to be naturally occurring, rocks are also needing to be naturally formed. Rocks can either be a mixture of minerals or they can be rock fragments that have been kind of compacted and cemented together. So we identify rocks by their mineral composition and the type of texture that an igneous rock has. Now, don't confuse texture with how the rock feels, if it's rough or smooth. When we talk about texture in geology, we're talking about the size of the actual mineral grains. So igneous rocks can either have a coarse-grained texture or a fine-grained texture. There are two different types of igneous rocks, and we classify these igneous rocks by where they're formed as well. Intrusive igneous rocks form from magma and they solidify, which means they cool, under the Earth's surface. So intrusive igneous rocks form inside the Earth. And because intrusive igneous rocks form from magma, depending on the temperature and the composition of that magma, we will have different types of minerals that will form different types of igneous rocks. A very high temperature magma tends to cool off as very dense and heavy minerals, like the mineral olivine, which is often found in oceanic crust. Low temperature magmas will cool as lighter and less dense minerals, such as the continental mineral of quartz. So we can take a look at what's called Bowen's reaction series. N.L. Bowen was the geologist that developed this chart. So it kind of shows how we can take two different types of reactions, what we call a discontinuous series of crystallization, where the magma will reveal several different types of minerals depending on what temperature they solidify at. Or we can have the continuous series of crystallization, where from a magma we can have one type of mineral kind of morphing or changing into another as the magma changes temperature. So, composition of intrusive igneous rocks. Continental crust, remember, the stuff that we're standing on, is very light in color and light in density. So continental crust is composed of very high levels of quartz or silica in the magma. And two examples of intrusive igneous rocks that form from a high silica magma are the examples of diorite and granite. These have very large crystals, so the texture of diorite and granite is what we call coarse-grained. If oceanic crust is composed of very low levels of silica in the magma, then we will get what's called either a gabbro or a peridotite. Again, these minerals are coming from low levels of quartz in the magma, so they're going to be very dark and very dense. So gabbro and peridotite are a low silica magma, also with a large crystals, so they have a coarse-grained texture. So remember, when we talk about texture for rocks, a slow cool means the mineral grains are going to be large, so we call that coarse-grained. You can see coarse-grained minerals with the naked eye. Fast cool, however, those minerals won't have enough time to make large crystals because once the mineral solidifies, then those crystals are frozen where they are. So a fast cool is going to have very tiny, tiny grains that are very fine grained. So you would not be able to see individual mineral grains with the naked eye in a fine grained texture igneous rock. The other part of the igneous family are the extrusive igneous rocks. Extrusive kind of comes from the word extrude or exit. So extrusive igneous rocks cool from lava and they solidify on the surface of the earth. So the composition of different extrusive igneous rocks, if the lava is very silica rich and we cool off very quickly, we can get what's called a rhyolite. Rhyolite, again, because of that rapid cool, is going to have a fine-grained texture. If the silica levels are very poor in the lava and it cools off very rapidly, we would get an example of a basalt. Basalt is often the type of rock that is found in oceanic crust. It's dark and dense, again, because it has silica poor levels. And it's fine-grained because it has small crystals. Sometimes there's kind of intermediate levels of silica in a lava, and we call those types of extrusive igneous rocks andesite. So kind of intermediate levels of silica with a kind of medium rate of cooling will give you kind of medium-sized crystals. In some cases, we can get varying types of texture with igneous rocks. A porphyry is what happens when magma starts cooling underground, and so it cools very slowly, allowing large crystals to form. And then, for whatever reason, whether it be weathering or erosion or maybe decompression, melting that drives that magma up to the surface, it cools a little bit faster. So then you get small grains in that igneous rock as well. So a porphyry has large grains in the background, which show the slow cooling, and small grains in the foreground, which show the fast cooling. Some magmas are a little gassy. We've talked about the composition of magmas and lavas in our last chapter. A vesicular texture in an extrusive igneous rock would indicate that magma, or lava rather, was very gassy and had lots of gases trying to escape during that cooling process. But with extrusive igneous rocks, a lot of times those bubbles will kind of form as the lava is cooling off, and those bubbles become trapped inside. So a vesicular texture is kind of like Swiss cheese. Pumice is a great example of an extrusive igneous rock that has a vesicular texture. Some types of pumice are so vesicular that they are the only type of rock that can actually float on the surface of the water. This has been Physical Science 2, Chapter 20, Part 2 on Earth Materials.